It was introduced around 1980s first. Analog model communication was that during that time. This only have voice communication, means human-to-human communication through voice. Later on, 2G and 3G, again it was a human-to-human communication, but voice.
Of FDP, we need to discuss published paper. So this is my published paper. As a single author, we have published, myself published. Okay. So the title of the paper is Energy Efficiency Performance. But already energy efficiency related works Abhijith sir already shown, and the performance of wireless cognitive radio sensor network with hard decision fusion over generalized alpha mu fading channel. And we know what is fading channels, but here in this paper I have shown generalized fading channels, and it is a alpha mu fading channels. There are several fading channels: Rayleigh fading channel, Raishon fading channel, Nakagami channel, Vibhull channel. So there are so many fading channels are there, but this is a generalized one. So whenever you submit alpha value or substitute mu value, you will get individual fading channels. You can see one graph. Suppose what you are observing here, when alpha equal to 1, mu is equal to 0.5. This channel is called the one-sided Gaussian. Okay? When alpha is equal to 1, mu is equal to 1, then it is nothing but exponential distribution. When alpha equal to 2, mu is equal to 1, Rayleigh fade. Means when you are varying alpha values along with mu values, you are able to find individual fading channels. Okay, so this is the work I have done for my project, and it is project is sanctioned by Government of India. So you can see the acknowledgement of this publication. See your funding. You can see this. This work was supported by Science and Engineering Research Board, SARE, under the Ministry of Development of Science and Technology, Government of India. This is the project file number. Okay, and very surprising, I want to share one information is that within 10 days it is published. Within 10 days. And even though I am a single author of this paper, I think they have seen this funding. I think they have seen these 3 lines and they accepted. So I have submitted 3 papers. 3 papers were like that. Within 10 days they published. And what I thought, okay, we have to get projects from government, then we can publish any paper very easily. That I thought. And this is, generally we know publication, but this publication is a special one. Publication through project. Normal publications are there, but publications through project is different. So this is a project and along with publication. Okay. So this is very important. So as a part of FDP, so we need to generate some figures. So I will show you a few figures, very good figures. So this is the first figure, basic figure. If we are able to draw this figure, remaining all the figures will come automatically. Okay. See here, you can see some few figures. You can also see. Okay. So it is published by Springer, Wireless Networks and Q1 journal. It is a Q1 journal. For this paper, I have received 1 lakh rupees from this institution. Within 10 days, but what was done 2 years back, but after submitting this paper, it takes only 10 days. But after acceptance and our director has given 1 lakh rupees for this paper. So there is an incentive policy in this institution. If we publish paper, we get more money. So this is only one author. I am able to get this paper. Thank you.
Based on that, you harvested energy. EC is the circuit cost for transmission and sensing cost. So what is the reward or transmission energy? H minus EC. That can be used for the transmission purpose. The transmission
time, transmission power is PT. Okay, so this is the throughput equations, and how we can design this PC. This is the equation 33. This paper if you follow, these are homework. The details you will get here. What is our observations? If you increase the sensing time, the reward energy I talk. This one. It is increasing. Then again, so there is an optimal sensing time for which you can the reward of energy to maximum. Similarly, if you look at the throughput, the same nature, there is an optimal sensing time where the throughput is maximum. And if you okay, fine. Now since our topic is basically we started with the basically wants to get the energy efficient network. So we need to measure the efficiency of the network. How we can measure it? Efficiency is basically total throughput by total consumed energy. Throughput already I've got. How to formulate the throughput. Now, what is the throughput? The total energy consumed, that is ES. ES is for the sensing part, ETR is for the transmission part. ES sensing part means when it is sensing, two things are running. One is circuit power and for sensing power. That is during this time. So PC plus PS, that now duration ES is done. ETR is basically transmission for transmitting power and running the circuit, other circuit. So here is you can see PC and here. So this is the ETR transmission during. So total energy consumption is ES plus ETR. So this is the throughput by total consumption. You will get the efficiency of the network. We have investigated the same here efficiency, different and or majority for that I discussed the Fisher rules. The throughput is investigated. You can find that and is better to giving better throughput or is giving less throughput, whereas majority in between these two. If you look at the energy efficiency, the thing is same. Since and is better, then or is lower and it is majority is in between. Okay. Now this is another technique that I told already, that sensoring technique, where the decisions are the channels are too much weighted, no need to take the decisions into considerations, better leave them. So this is one kind of network. It's a D2D network basically. Here number of D2D users are there. They are sensing the information sending to the FC. There are some dedicated power devices are there. Dedicated power devices. These devices will collect energy from here or this CUC. And then once it is channel is free, it will transmit to the respective. This is the scenario. Now since I told, if the link is very bad, better instead of taking the decision or transmission of these associated devices with this link, eliminate them from the process. So what is the criteria that channel conditions we can select only when the channel mod of this channel, the channel coefficient is greater than some predefined threshold CT. Then only we can select the user associated with this channel. So what is the probability that U number of users is selected? That is 39. It is designed by yourself, Srinivas sir. This design. Okay. The entire sensory concept basically he contributed. Okay. So first sensing, then sensoring, then harvesting, then transmission. So first harvest, sense the channel with the freeze is not. Those who are bad, leave them. Then allow the rest to harvest and then go for transmission. What is the advantage? What will you say? The harvesting scenario. The harvesting energy, there is nothing new. See here, where the analysis is different.
And I would like to I'd like to thank Professor Srinivas for inviting me to be part of this evening. Today I am going to talk on components of the network. This is my talk outline. First I will introduce that topic, then communicated technology, then I'll come to the collaborative sector sensing. Different transmission modes, sensing through radar, green communication, traditional energy harvesting application and switch, sensing based energy harvesting, energy efficient CR network, energy CR level sensoring based B2B communication. These are basically my own studies and some studies made by some renowned researchers and which are published in Aicte transactions, wireless communications. These last four topics are B2B communication, energy relay network, and throughput maximization from underlying multi of CR network with RF energy testing and future communications. What are the requirements of 5G and 6G? Before coming to that 5G and 6G, I would like to recall the other generations, previous generations. If you look at the previous generations, they have their own focuses, and that focuses change generation wise. If you look at the first generation, it was introduced around 1980s first, around modern communication during that time. There was a voice communication, means human-to-human communication through voice. Later on, 2G and 3G, again it was a human-to-human communication, but voice and little bit text was added here. It was little bit data entry. But if you look at the 5G, 4G, then what happens? That along with this voice, more number of applications or services that becomes coming from the people side. So that 4G communication was only massive data communication. Now we are in 5G, going towards the 5G beyond. So if you look at the requirements of 5G, it's a higher system capacity, higher data rate, reduced latency, massive connectivity, energy saving and cost reduction. If you look at all these requirements, basically it is focusing on connecting the IoT and industrial